Appreciate the time to be here today and talk about this. This topic is near and dear to my heart, and hopefully coming through loud and clear, and have the slide and everything. So, what I want to talk about today is some strategies around cybersecurity, and this is not about people and wallets, but more when we start to get into these highly decentralized environments like this. How do you even hope to build a security model that goes through the whole ecosystem? Most people probably don't know me, but I work at a big company called Kudelski. We're a 60-year-old French company, and we're one of the largest sort of global integrity providers. We do physical access, digital media. For instance, we're probably the one that's in the way when you watch a DVD. We invented that sort of DRM technology with operations and IoT security as well. So when we think about this, and I'm one of the global architects there, we take a look at the general methods about how to protect the entire ecosystem. And especially what we've been talking about during this event is in the world here now where the entire thing is becoming digital. How do you actually guarantee, and it's really important when it's all digital, it's 100% guarantee. How do you do that? How do you guarantee that you can trust every electronic transaction? That's a pretty tricky thing to do. So, I'm not going to sit here and explain trust. I'm not going to explain why people need to trust the system. We all have our own reasons. We trust it because we want to be anonymous. We trust it because we want it to work better. We trust it because it's our money. We trust it because it's, our critical information. We each have our own little reasons. But you have to think about the exercise we're going through here. We're trying to essentially build a 100% proof full ecosystem that works in real time or speed of human, at least, with that super scary word, secure. What does secure mean? It means a bunch of different things for a lot of people. It's reasonably easy, I'll put that in quotes, I guess, to secure a centralized system because you can control all the pieces. As you start to scale out with these sort of full decentralized environments, you may not control all the pieces. It's maybe almost assuredly that you don't control all the pieces. I guess that's the point of being decentralized. So how do you guarantee security? What you don't do, and what I appreciate about the conversations I've listened to here today, is nobody is watching the train wreck happen. They're not like, let's just build these things and sort of hope it works. People are going in like eyes wide open. Let's build this the right way from the beginning. And that's a huge, credit to everybody on the project here, that they're focused on all of the intricacies of how things intercommunicate and operate within. And so, traditionally, and when you think about security, it is confidential integrity availability, right? It's got to work all the time. The information has got to be true that you stuck there, and people shouldn't get access to it who don't belong to, right? It has to be confidential in that way. Of course, you need to expose it. Full anonymity doesn't particularly work in the real world. But what's really interesting that a lot of big decentralized projects forget is there are rules of society. There's the legality point. Is it okay to use in the place that you happen to live? We could debate whether or not it's okay that a government can do that. But the point is they do, and we're all citizens of somewhere, and it's legal for us to do or not do things in certain situations. And so, people who are attending probably know what a blockchain is, and we know the standard things that a blockchain has in it. And these are all things that sort of the vast majority of, we'll call them ledger-based projects, try to do in their own sort of different manner. But when I take a look at systems like this, I like to break it down into sort of a flow when I think about the information and how I handle it. Essentially, especially in systems like Nexus, where we're talking about physical devices in here and not just a bunch of software exchanging data, we have to think about a trusted device that's either gathering the information I like or maintaining it a way that I want, sending that data accurately to the place that it belongs with a full security tunnel end to end, written to storage that can't be changed once it gets there, but then a full set of operational controls that catch positive use cases, negative use cases, sort of the tracking of where stuff goes, because I want to be able to respond ultimately in 0 seconds if something starts to go wrong, right? That assertion that we made at the very beginning, which is this thing needs to be 100% secure 100% of the time because this is my full digital system. There's no human in the way anymore to be, oh, we'll just wait till the nightly settlement and go deal with something. That's not available in the system anymore. So when we take a look at this and apply to the modules in a big system, it starts to look something like this. I have a bunch of trusted math that goes inside some trusted code, right? I build some code. And then those go together as trusted modules that get installed in trusted devices that do something you want to trust, right? It's a layered effect all the way up. This is maybe a pretty controlled process in and of itself because we've been building devices with really highly sensitive things in them for a really long time. But what we haven't really done is we haven't decentralized that in a manner where we then start to trust the communications between things we don't control, things we may not have fully tested, things that we may disagree with the method of operation. And the more and more critical operations that we do to this, we're going to run into this sort of end, right, that we get to here, which is there are some untrusted IoT devices participating here. You can never trust a human to do the right thing, but you have to do this with end-to-end security. So when you break apart this project, how do you layer these components? So take a sort of look at the main graphic of the projects and how they fit together here. This layers quite nicely on these sorts of things because these are the things you have to do. I need trusted math. Great. Oh look, quantum. That's pretty good trusted math. I need some code and some modules. Okay. So I want some on the 3D chain. Those are some trusted components. I want cryptography. Okay, that's quantum. I can trust that. Governance and record keeping. Okay, I have to trust those. We end up with a bunch of trusted components that we can say, look, I've got the first 2 or 3 or 4 layers of this that I can apply to each one of these things individually, right? I think that's a reasonably interesting process that I can go through as I'm building out these sort of blocks, right? These are sort of scalable, almost state machines. Maybe it's too complex to be a state machine, but they're definitely reusable modules that people want to use for certain things, or their assertions, right? I assert that it's scalable, and here's how I prove that. So as humans, we ask questions, right? The smart humans would say, prove to me that the math and the randomness is good and that the information is safe. But honestly, most people in the world just say, please don't lose my stuff. Like, yep, you put satellites in the sky, and I know it does something with my phone, and it's just magic. Most people just think all of this stuff is magic. They don't understand the components. And so they just say, please don't lose my stuff. There have been a lot of problems in the world of blockchain. You all probably know all the stories. Blockchain is usually a lose it and it's gone situation. Of course, there's the fungible and non-fungible tokens, but generally when you lose it, it's gone. Maybe some insurance gives you back. Maybe you can create the token again, depending on the environment. Maybe you fork the chain, right? That's happened in the past. But as the world is operating, the more and more we get digital, we can't say, oh, sorry, lost all your stuff. Because humans will never abide by that, no matter where you live, no matter whether you're trying to be anonymous or not. You don't want your stuff gone. And so I think to myself, right, I've been doing this for 25 years almost now. I ran a big security team at PayPal and a large US brokerage. And I think through the scenarios of how I source security teams in the past. How do I actually find somebody I can trust to look at the pieces of a system when I need them to, and in the manner I need them to. So should I think, okay, the world is decentralized. There's a bunch of decentralized people out there who are good at things. Do I trust a bunch of individual people? Or do I partner with a company or a subset of companies who can keep an eye on the whole end-to-end ecosystem? When you think about how complicated some of these systems get, it really matters if you have these sort of testing harnesses and philosophy that it matters from end to end, not just the state of components. You can sort of debate which is better. Of course, when you go out there and say, I really need to test Java code, who is the best Java code tester in the world? You'll probably find an independent practitioner who is the best Java code practitioner. But what that person probably is not is a hardware tester. That person probably is not a cryptographer. They're a Java person. And so it's really hard to find a bunch of experts when you're trying to find 50 or 60 of them. So maybe it makes sense to partner. But I heard something said a couple of hours ago that's interesting, is that, especially in this system here, each component is being built so that it validates what's coming in. It sort of makes sure that that information is usable, right? It verifies that it's safe, right? Maybe it's atomic, depending on the operation. Is it enough that each module makes sure that it functions correctly? I argue no, because we don't just use them singly. We use them as part of a whole. It's cool that there's satellites flying around, but if they don't participate and send information right, what use are they? It's interesting that the IAM system does something. It's interesting that the blockchain reaches consensus. It's interesting that the keys are saved over there. But by themselves, these modules are just modules. They have to be used by other things that try to talk to them. So I think about a couple of layers when I look at how I fit the kind of test I need against a module, a combination of modules, or a set of systems. And I break them into two sort of categories, which is maybe for the IT people who are listening to this, different than how you've seen these terms used before. There's a sort of concept, fit for use and fit for purpose. And I look at it slightly a different way. Is this thing fit to use? Does it work, and is it secure? Right? So I'm building AirPods, and I know they're fit to use because they work, and I can't tamper with them. I can't rip them apart. Whatever. I have proven that this module is safe. I've built a little state machine, and it does its function. But then I have to think to myself, is it fit for the purpose that I want to use it for? Is this the right particular tech for this use case? And is it safe as part of my whole system? When you're, for instance, selecting, an anti-malware vendor or something, more traditional like that, you would say, you know what? If it's in Gartner or Forrester, if it's in one of the big magazines, and it's in the top 10, it's probably fit for use. This one got an 87, that one got an 85, and that one got a 94. Like, okay, they're all probably fit to use. But if you have a particular offline use case, you're in a factory, you have a particular type of hardware, you say to yourself, is it fit for the purpose that I want to use it for? Just like you would ask this kind of question around quantum cryptography or quantum factoring, certain types of elliptical curves. Yep, they're all fine with math, but are they all fit for every purpose? Of course not. And so when you look at selecting security testers or security products, or even testing certain things, you have to say, how do I prove that it's fit to use? And how do I prove that it is fit for the purpose that I'm using it for? Because that, to me, changes how you test things. And so I don't think it's a good idea. You kind of have to ask yourself, is it a good idea that I just trust that these secure components that are now fit to use will always interact safely? Of course not. We just saw, 10, 15 minutes ago that there is a way to game the system, even though these components in and of itself, they were probably just fine. But once you started adjusting variables as a human interaction with it, they weren't safe. Well, actually, it probably was safe. It just did the wrong thing, which is another, oh, it did the wrong thing safely. And that's still probably a problem, right? The challenge on top of this is that humans will be there to mess it up, no matter how good you build something, right? They will interact with it wrong. They will mess with the deposits and withdrawals. They won't have their bank account. They'll be in the wrong country. Now, there's a pretty interesting problem in today's day and age with decentralizing something across country borders, especially now that a lot of countries are trying to build sovereign rules to, you could say, control the citizens, but legally you sort of think, how do I keep track of what everybody's doing so that they pay their taxes, so that I understand which of them could do harm to others, so that I understand, which of them are maybe behaving in a way that is unacceptable to society. Again, we could argue whether or not those are controls that we should apply to humans. But when we take a look at our system, we have to apply those things, whether or not a human is going to misuse it kind of at all, or even use it at all. And unfortunately, a lot of the projects that are out there, especially some of the decentralized ones where they're decentralized teams, they have become pretty hard to use. You need to be a technical expert to use the system. You have to download something and compile something and put a wallet and then join it to this. And then you got to go buy some Bitcoin to trade it for a token to put it on the thing to finally use. It's 10 or 12 steps. That process right there is a human process. The vast majority of the time, humans can mess things up. And I think it's really easy to mess things up. So that, as one of the soapbox things I have, is not only do we need to make these things safe, but we need to make them easy to use so they're safe for people to use. And if I don't sort of enforce that along the way in a project, I don't think I've done my job right. And so if I break down this stack again with areas that I think you should sort of focus your resources and think about, do I need the person who's really good at the thing? Do I need a team of people who are good? Do I need to hire a big company who's good at putting things together? Of course, all of this is arguable. But when I take a look at math and code, generally speaking, really smart PhDs, coders, especially in this space, people have been doing this for a lot of years. They're really good at it. You can generally trust an expert to tell you that you have made mistakes. There are some pros and cons with trusting a particular expert, especially if there's multiple languages involved, multiple types of math. One thing I've learned over the years is a PhD is not a PhD, right? You could be a quantum physicist and be bad at algebra. You could know elliptical curve theory really well, but not know how to do logic math. And when you're, doing things and you start to say, well, just look at my 3D blockchain, they go, well, that's not math. And you say, okay, well, let's figure out what's underneath the covers, and you boil it right down to, and there's an algorithm, and they go, oh, I can look at that. And so that's, I think, what's appropriate for an expert. And so in a decentralized project, when you're building a tiny thing, it's important that you bring in that expert, which a lot of projects do, to look at the math and then look at the code. But then you got to turn that into something, right? It's got to be a module, or you got to install it on a device. It's very unlikely that the person who can do a really good code review, and I said this before, can also pay attention to the interaction of the modules as they move within a trusted system. Sometimes they're deployed on devices, and there's some pretty sophisticated attackers out there who can very simply look at your device and tell you what it's doing. You can glitch it to get the key and all that kind of stuff. So it's really important, depending on the module you're building, if you're going to deploy it, in something embedded and it's going to live for 20 years, the security around that is a lot different than if you can deploy it in 10 seconds to replace it. You sign it versus hide it versus all these different tricks. And then devices are a whole nother beast in itself. You throw a satellite in the sky and you basically never touch it again. You just operate it. And while you're operating it, some things can happen, right? You have to build control processes around that. don't need to trust the device anymore. You have to trust the communications and the operations and the process. Maybe two people agree to send a command, but they send the wrong command. Then what? Maybe a bad guy takes over your antenna and sends the wrong command. Right? Is that you didn't trust the device? No, you lost the process. So it's really important that I think you bring in, I would say, an expert partner, right? Somebody who's good at that kind of module, that kind of device, to give you their opinion on if you're misusing or controlling inappropriately. This is a bigger surface area, especially when you start to combine maybe more than 4 or 5 modules, because these things interact in a very complicated graph sort of way. Even if you can address everything and find it in the ecosystem, you can't always know that each node or each path is secure. And then when you put it all together, I happen to work at a cybersecurity company right now, and I think we're an expert partner for a lot of the really, really hard, challenging, what do we do now use cases. But I actually believe it too, that when you start to build a complex system, it is really hard to trust a couple of independent people to be able to look at all of the aspects of the ecosystem in a way that combines years and years of experience or lots and lots of other projects, right? If people have worked on a project for 4 years, they might lose sight of what else is happening in the world. They might not have that new attack harness that people are using. And so as you go down here, right now you're building trusted capabilities that do critical operational things. That's, I think, where end-to-end testing comes in, expert partners come in. This could be a team of 5 people, right? I'm not saying hire a big, expensive company. I'm saying you go from individual, really smart person to very specific experts to a grouping of people or a company that can focus on this whole end-to-end security of your project, of your ecosystem. Because the minute you touch an untrusted environment, which is human society, all this top layer of stuff has to be in place. So I ask these sort of questions to leave you for the day, which is, can module experts do a better job than system experts, right? People who are good at building modules are really good at building them reusable, but the people who put the system together have to consider operational use. Like, you have to think of the pros and cons, fit to use, fit for my purpose. If you put this in the real world and expect money to touch it, like actual money coming in, then banks might need to trust it, governments might need to trust it, big actual enterprise systems might trust it, and they're going to apply the current world rules to you. And it makes a lot of sense, especially for those use cases, to bring in the air cover of a company who can give you that big company look and report that these other sort of partners in your ecosystem would need. You have to decide how much proof is proof enough, right? Do you need a report? Do you just want it fixed? And I can't stress enough how much human beings can mess things up. A single mistake by a human being, we've seen in the past that one person deployed a contract wrong and all the money went away. We've seen people sending money to the wrong wallet address. We've seen entire token amounts burned by mistake and having to recreate, right? That's kind of a single mistake. When these things are in operation for 5 years, that single mistake can't exist anymore. You can't just recreate an entire ecosystem of something that's up and running. One thing that I do think we'll see more of is independent cyber practitioners who get together as more of a gig society, right? This whole like Fiverr for security testers. It's not really a thing because there's so few of us, but you know what? This whole decentralized gig society for decentralized project testers or something could be a thing. And it's pretty interesting that they would think, I'm really good at this kind of module. I'm really good at putting these kind of systems together. We can test the whole thing, hire us as a collective. That's a pretty interesting thing to think about. Forget the top half of this slide for now, but when you look at a project, this particular project, Nexus, is well underway with development, but there's a lot others that people are involved in that haven't done as good a job. And when you think about the pieces here that go along with that stack diagram from before, you have to think, do I need advice, right? Do I need somebody to come in and give me advice? Is what I'm doing legal? What are my threats to think about before I build, right? Do I need people to do fundamental research? Do I need to find a bunch of PhDs who are a specialist? Do I need help building it? You know, we all are bringing in decentralized coders and builders and architects, especially to build projects like this. How do I make sure that they have the skills that I need? And then when you're all done, you bring in the right people to test it. Like these 4 stack diagrams are what every project needs to do at some point if they're actually going to be useful in the real world. Whether you hire a company like mine, whether you get a bunch of decentralized people to do it for free, whether you go to a university and partner with grad students, these are the buckets that you end up doing along the way. And so I'll leave you with that, and thank you for the time. And I want to say, please reach out. I think I had at the beginning, I am Scott Carlson on just about every channel, and I work at Kudelski, so I'm happy to help. I'm happy to answer questions about cybersecurity. And you know, as you please Nexus and others who are participating in this ecosystem, as you're going through this and building all these modules, please keep this in mind as you go through the thing, right? That you want to guarantee that from the trusted source all the way through operations is there all the time, because that's what's gonna be necessary to make this thing work long term. So thank you. I appreciate the time today, and I'm happy to answer any questions if there are any.
We will see if we can, we've been kind of like porting some of the questions from the G chat, stuff like that. I'll see if anything pop up here. I mean, what are some of the, I have a question for you. What do you see as some of the biggest threats, or I guess coming from a security background and looking in from that security window to the blockchain industry? Like, what's your perspective of that? Like, you know, as far as security protocols, things like that. How do you see that?
Yeah, there's maybe been a steady increase in the capabilities, because first people needed to make it work, and then they needed to make people use it because generally there was a token involved, and then they make it safe. And so now we're starting to get a lot of reusable libraries that work, right? The rule is always don't invent your own math, don't invent your own cryptography. Only if those 2 things don't do what you want, then build yours. And in the community, we're finally starting to get, you know, curves that work, multi-party that works, encryption protocols that work, certificates that work, signing that works, end-to-end tunnels that work, hardware that we can trust. And I recommend that people use those things unless there's an absolute reason why you need to invent something. It's better to use these building blocks that we know have been tested, tried and true, than to just invent something for the sake of inventing. And so when we're looking at the world of blockchain, right, the whole privacy thing with zero knowledge proofs and ZK snarks, and the whole idea of being quantum safe is really interesting, because if you assert that these systems need to last now for 10, 20, 30, 40 years, and computers will get faster, your algorithm better be good, especially when you're deploying something that needs to last a long time. Because generally in the rule of cryptography, you have to kind of know that at some point in the future, there will be a computer that could break this. Really, the trick is how far in the future. And that, I think, is sort of the game here with a lot of these projects, which is, if you keep track of the sort of big things that are happening, right? We're solving some of the wallet problems. We're making the user interfaces better. Those are a problem. Those are okay. We're starting to add more high availability to chains. We're starting to add more node health indicators. And so when I look at sort of the general cybersecurity, we're going from, great, people are now using the languages that are safe with the modules that are safe. They're building on top of chains that have been out long enough with enough value associated with the really smart attackers have really given it a go, and they haven't broken in. So you can trust the foundation. And so now we're doing communications, which is IoT and algorithms and embedded sort of key stores. And using those things that are there that are tamper proof, I think enable a lot. And I think in the case of Nexus, the communications between all these points are using well-known safe methods. And that, I think, is really important, because the minute you use something that's not safe, the minute you lose your software supply chain and start using algorithms that have never been patched, you run into all these problems that we see. throughout time. And what I hate, doing this for so long, I hate people losing because of a password thing, a phishing thing, you forgot to patch, or it was one of the highest CVSSs in OWASP that have been there for 50 years, right? If you lose to those things, you didn't even do the basics, and that really irritates me. And so, as long as people are using these modules, I think that's half of the problem, honestly.
Awesome, Scott. Thank you. From basically, let's see, what do you rate kind of the security of some of the bigger cryptos, like, Bitcoin, Ethereum, Binance, Cardano? Like, how do you see them? Like, what's your kind of take on that?
Well, let's just do Bitcoin and Ethereum real quick, because in the case of Bitcoin, the algorithms that make that work, I don't know of any flaws, and nobody has seemed to have found a flaw in 10 years that have made the system itself not be trusted. The things that plug in, the wallet, the website, the purchasing process, the exchange process, the way you use it is where we get tricky. So this whole world of swaps and DAOs and stuff, that's where you get to a problem, because you started to use the chain for something that it wasn't, because you decided that the token has value. In the case of Ethereum, again, the math is good. The proof of algorithms all seem to work. The ERC standards have been extended a few times, and they seem to be able to contain the information that's in there. And people like to mint it. The thing that really has always happened here is that the contracts can still be bad. Thankfully, we're getting better at that. The wallets can still be compromised. Both of those things have humans at the beginning, if you notice. And there is no way something will ever get to 100% when a human writes a contract and then has to deploy it themselves to do critical 100% logic. Like, one of the four things will fail in that process. And I think that's the problem Ethereum will generally always have, because you just can't test something enough, no matter how trivial it is. I mean, maybe you can, but
and it's immutable too. So like, once you deploy the
yeah,
contract, I mean, you're stuck with the contract. And I mean,
broke forever.
even just like overflow vulnerabilities, like, remember from the 90s, overflow,
Yeah.
and all of a sudden they're back.
So take that, and you're like, okay, I could just deploy version 2.0 of the contract.
Yeah.
On a satellite that's encrypted that you can't change out.
Exactly.
Like, okay, that's a prom burn.
Yeah.
Or you got to plug a cable into it. Like, that's not a contract you can fix.
Yeah.
This
and
is
like you said too, people need like prepackaged things that, are already standardized, and not reinventing the wheel, because human error is a big thing, and you need to have lots of eyes on it, right? And even the virtual machine itself, like, the virtual machine shouldn't tolerate, I mean, it shouldn't tolerate any overflows. It shouldn't allow overflows to happen. I mean, there's no point. And I mean, architecturally, it's just like, I think there's a lot of safeguards that could be put in the proof of concept phase that we're in now for Ethereum, right? And I mean, it's not easy to redeploy a contract, and even like, predetermined gas limits and things like that. I mean, my opinion is, I've just seen, it looks kind of like my code was when I was 12, where I was just like, hey, this is cool. I'm going to put this in, and I'm going to add this in, and I'm going to add this in, and look at this, it's all great. And then 5,000 lines later it goes, and it implodes, because if you don't assess the structure and design it with all these things in mind from the gate, you just end up with massive security flaws. I mean, even, you brought up quantum resistance and stuff. And I mean, ZK snarks, I'm not entirely convinced of those either. They're computationally intensive. They're difficult to verify. There's very little crypto analysis on them. And they were written by JP Morgan Chase, so I'm sure there is some merit to them, right? But still, like, I'm of the experience that, like, you want a couple decades of crypto analysis on something before. Like, that's why we use lattices, right? Because lattice-based cryptography is very well understood, right? It's not as widespread in usage, but it's got decades of crypto analysis, or, different algorithms. And it's just really important. Like, never write your own crypto, because you don't know what you don't know, right? And it's just,
it's this is the whole make it work, then make it better.
Yeah.
Then make it foolproof. It's this process. And, what C has been around since 1971 or something, and we're still messing C up. That's 40 years.
Yeah, I know.
So we got a good 20 years to go before we get good at this. And maybe the last thing about what you're saying about attacking things is, there's always somebody smarter than you out there. Your kind of goal is to solve every problem so that a nation state attacks you. And your security rule should be the nation state will always win. If a nation state attacks me, great. Then I turn on the other controls about response and safeguards and stuff. But all the way before that, you got to check off these things that are known permutations that we've been working on.
Awesome. Well, do you have any further comments before we close?
I don't. I'm available to chat on Twitter or pick a place.
Yeah, I think we were trying to get on
yeah.
the horde, so let's get on a call the next couple of weeks and kind of discuss.
Absolutely. Yeah, let's talk. Love to.
Awesome. Cool. Thanks, man.
Thanks.